Okay, welcome back. Here I'm going to show you some equations of ellipses. This ellipse right here would be the graph of the equation x squared over 25 plus y squared over 16 equals 1. In this particular ellipse, the center is at the origin, 0, 0. The vertices are at 5, 0 and negative 5, 0. So A, the distance from C to V, is 5. And you can see that in the equation, the number under the x squared is 5 squared. It's 25. The distance from the center to a covertex, or half of the minor axis, is 4. And that shows up in the equation here. This 16 is 4 squared. So the number under the x squared is a squared. That tells you how far to go from the center to get to a vertex. The number under the y squared is b squared. B tells you how far to go from the center to get to a covertex. And then here, the foci are at 3, 0 and negative 3, 0. So C would be 3. And yes, a squared is equal to b squared plus c squared. Now here is the ellipse x squared over 16 plus y squared over 25 equals 1. Do you notice the difference between this equation and the one we were just looking at? In the last one, we had the bigger number 25 under the x squared and the smaller number 16 under the y squared. But now it's the other way around. Now the 25, the bigger number, is under the y squared, and the 16, the smaller number, is under the x squared. So that gives us a vertical ellipse, an ellipse where the major axis still has length 10, but now it is vertical. So the number under the y squared is 5 squared. So to get to each vertex, you would start at the center and go 5 spaces in the y direction, up 5 to 0, 5, or down 5 to 0, negative 5. Under the x squared, we have a 4 squared. So if you start at the center and go 4 spaces in the x direction, you get to not the vertices, but the covertices, other points on the ellipse. And then C would still be 3. But this time the foci are above and below the center because they are always going to lie along the major axis. Now here is the same ellipse we were just looking at, only shifted over. Instead of x squared, we have x minus 2 squared. And instead of y squared, we have y plus 1 squared. So that just shifted everything over 2 spaces to the right and 1 space down. 2 spaces in the x direction and negative 1 in the y direction. So that now the center of the ellipse, instead of being at 0, 0, is at the point 2, negative 1. And I just now noticed that this is backwards, so let me fix that. We are still dealing with an ellipse with a vertical major axis, one that's taller than it is wide. So I do want the bigger number under the y part of the equation. So A is still 5. So to get to the vertices, you would start at the center, wherever it is, and go 5 spaces in the y direction. So if we started at 2, negative 1 and went up 5, we would be at 2, 4. And if we went down 5, we would be at 2, negative 6. So the vertices are at the center, 2, negative 1, but we take that y coordinate and we add or subtract 5. And the covertices are also relative to the center. If you start at the center point and go 4 to the right or 4 to the left, that traces out the minor axis. That gives you the points on the ellipse that are the covertices. And the foci are still 3 spaces above and 3 spaces below the center. So they are along the major axis, C units away from the center. And in this case, C was 3. So here's what's true in general. The equation for an ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1 if the major axis is horizontal, or it's x minus h squared over b squared plus y minus k squared over a squared equals 1 if the major axis is vertical. The difference is, now the a is always the bigger number. The a always stands for half of the major axis, and the b is half of the minor axis. So a stands for whichever of these two numbers is bigger. But if the bigger number is under the x part, then we have an ellipse that's wider than it is tall. It's longer in the x direction than in the y direction. And if the bigger number is under the y part of the equation, then we get an ellipse that's taller than it is wide. It's longer in the y direction than it is in the x direction. Either way, x minus h is squared and y minus k is squared, and the h and the k give you the coordinates for the center of the ellipse. Each vertex is a point on the ellipse a units away from the center along the major axis. The length of the major axis then would be 2 times a. The length of the minor axis would be 2 times b. And there are points on the long side of the ellipse, b units away from the center in the direction of the minor axis. Those are what we were calling the covertices. Each focus is a point inside the ellipse, c units away from the center along the major axis. And I was saying earlier that a squared equals b squared plus c squared. You could rearrange that to say c squared equals a squared minus b squared. So of those three numbers, the a or the a squared is always the biggest of the three. And the eccentricity, E, equals c over a. Remember, I just said a was bigger than c, so c over a is a smaller number over a bigger one, which gives you a number less than 1. So the eccentricity will always be less than 1 for an ellipse. And you could rearrange that equation and say c equals a times e, or a equals c over e. The larger the eccentricity, the more elongated the ellipse. The closer to 0 the eccentricity is, the more circular the ellipse is. And if the eccentricity were exactly 0, then you would have a perfect circle. So now, with all that in mind, with all that at our disposal, let's work through some examples. Find the center, vertices, foci, and eccentricity of the ellipse x minus 3 squared plus y plus 4 squared over 9 equals 1, and sketch the ellipse. Now this right here does look like the kind of equation we were just looking at, right? One of these, except there isn't a number under the x minus 3 squared, but we can think of it as x minus 3 squared over 1. So we can pretend there's a 1 down there. So first of all, the center of this ellipse would have to be at the point where x is 3 and y is negative 4. Okay, that gives us a reference point. Everything else is going to be relative to that center point at 3, negative 4. A squared is the bigger denominator. So here that would be 9. And if a squared is 9, that means a is the square root of 9, which is 3. So that tells you how far away from the center to go in the y direction to get to the vertices. If we go up 3, we get to one of the vertices at 3, negative 1. If we go down 3, we get to the other vertex at 3, negative 7. So the vertices are at 3, negative 1 and 3, negative 7. And the line that connects those vertices is going to be the major axis of the ellipse. then the smaller denominator is 1. So that's b squared, and then b would be the square root of that, which is just 1. So if we start at the center point and go one space either way in the x direction, we get to points on the ellipse, and connecting those points gives us the minor axis, which has a length of 2 times 1. So there's the minor axis. C squared would be a squared minus b squared. So 9 minus 1, which is 8. And then that's c squared, so c would be the square root of 8, which is approximately 2.8. So if we start at the center point and go in the direction of the major axis, that is up or down, approximately 2.8 spaces, we get to the foci. So there's one at the point where x is 3 and y is negative 4 plus the square root of 8, which is around negative 1.2. And there's another focus down here at the point where x is 3 and y is negative 4 minus the square root of 8, which is approximately negative 6.8. The eccentricity is c over a. Here that's the square root of 8 over 3, which is approximately 0.94. That's a fairly large eccentricity. So we do have a fairly elongated ellipse. It is a lot taller than it is wide. And to actually draw the ellipse itself, that's pretty easy once we have the major and minor axes, because we just make a round curve that goes around the ends of those axes and looks nice and symmetrical. Okay, next example. What's the equation for the ellipse with center negative 5, 0, horizontal major axis of length 10, and vertical minor axis of length 4? Okay, so here's our starting point. The general standard form of the equation for an ellipse, since I said that it has a horizontal major axis. The major axis is horizontal. So that means it's going to be longer in the x direction than in the y direction. The bigger number, the a squared, goes under the x part of the equation. Now, for the center to be at the point negative 5, 0, that means that the part of h is being played by negative 5, and the part of k is being played by 0. So this looks like x minus negative or plus positive 5 squared over a squared, plus y minus 0 squared over b squared equals 1. The horizontal major axis has length 10. So that's 2a, which means a is 5. And so a squared would be 5 squared, 25. And you'll notice instead of writing y minus 0 squared here, I just wrote y squared. And the vertical minor axis has length 4. 2b equals 4, so b is 2, and that means b squared would have to be 4. So, okay, you can't see this real well, but it's x plus 5 squared over 25 plus y squared over 4 equals 1. And so I'll stop this video right here and come back in part 3 with a few more examples.